It was 10 years ago today that Spheres, those bowling ball-sized experimental satellites, were first tested on orbit. Since then, they've tested everything from rendezvous and docking to sloshing liquids to even student robotics competitions. Now, to add to that legacy is the next-generation robotic free flyer called Astrobee, set to fly to the station in 2017. I spoke with the project manager, Chris Provencher, at Ames Research Center to get the buzz on the bee.
Astrobee is a free-flying robot that we're developing for inside the space station.
It's like a bee?
Like a bee, actually. Yes, busy as a bee and buzzing around like a bee.
Wow.
This robot, we have three main things that we want to accomplish with it. The first is that we want it to be a free-flying camera inside the space station to help flight controllers and payload controllers on the ground have better situational awareness into what's happening inside the vehicle. Right now, when they want to see inside the space station, there are some camcorders set up, but those are in fixed locations, so this would really empower them to get the view that they want by being able to fly this robot around with an HD camera and to see what they need to see.
So what does it look like? Does it look like the Sphere stuff, or are we talking about something totally different?
It's about the size of Spheres, so Spheres is more rounded. We're looking at something that's actually cube shaped and about 12 inches per side. So right now we're still in the design phase. We've identified all of the capabilities that we wanted to have, and we're working on a design to meet those capabilities, and we've been doing prototyping along the way as well.
Where did the idea come from?
The idea is to really help with humans on their missions. So we're not developing a robot to perform robotic missions. We want a robot that can help crews on their human exploration. The most limiting resource is crew time. And so the idea is to take over some of the tasks that the crew do to let them focus on science and experiments and the research and put over some of the more tedious tasks onto robots.
So in theory, they could be performing an experiment, and this little Astrobee could be over their shoulder filming what they're doing, right? Exactly.
One of the things that we wanted to do is mobile sensor tasks on the space station. Right now, the crew has to do a lot of things to survey the environment inside the space station to see if it's safe. For example, they have a sound level meter, a handheld meter, that they measure sound levels to make sure it's not getting too noisy and dangerous for their hearing. So that's something that the robot could do. They measure air quality to make sure that the CO2 is getting scrubbed out of the air properly. So if we put that sensor on the robot, that's another thing that the robot could do. Another example is we're working with a group on automated inventory management. So there are thousands of pieces of equipment on the space station that have to be tracked, and you have to know where it is. So right now we're working with a group to, they're looking at putting smart tags on pieces of equipment and then having readers that can track where those pieces of equipment are. And part of their solution is to have a free-flying robot with an RFID reader that can look for lost pieces of equipment. So we're working with them on that as well.
You guys control it from the ground, or how does it control?
We do control it from the ground, or it can be controlled by the crew. Either way, it's remotely controlled. And one thing that we're trying to do is make this robot as autonomous as possible. We don't want the crew to have to pull this robot out of a locker and set it up. That kind of defeats the purpose. So we want this thing to be able to fly around inside the space station without the crew having to supervise it to accomplish its tasks. So as part of that goal, we're also building a dock. So sometimes we call it the Roomba for space, right? So we'll have a dock inside the space station where it recharges its batteries and then is able to undock via remote control and perform the task, all under the supervision of ground controllers and not having to interrupt the crew.
And this plays on a rich heritage from you guys at Ames and the robotic capabilities.
Yes, so actually for the past few years we've been doing tests with Spheres, which is another free-floating object on space station. We connected smartphones to it so that we could establish a link to the ground, and we tested remote control from the ground. So yeah, we do have some experience with this. We've been working with JPL on this project, and we've also, NASA has mechanisms for engaging small businesses. So right now there are 3 small businesses that are working on developing appendages that would attach to the robot, which is pretty neat. And so we're also starting to do the same thing with academia, have universities propose what they would attach to the robot. When this project started, one of the first things we had to do was name it. And so we held a public competition to name the robot and come up with a mission patch for it. And it was really inspiring to see all of the creative ideas that were submitted And that's how we got the name Astrobee, because when we described what it would be like, people thought of a bee buzzing around inside the space station, staying busy. So that's where the name Astrobee came from. And it was just a really great reminder to us about how cool our job really is.